It started like any good cosmic mystery does, with something small, faint, and completely unexpected entering our neighborhood unannounced. One moment, space was doing what space usually does, minding its infinite business. The next, astronomers spotted something slicing through the darkness at incredible speed, a blur of light that didn't belong to anything familiar. They called it 3IATLAS, the third interstellar object ever detected passing through our solar system. And just like that, Earth got another uninvited guest from deep space. Now, let's be clear. Space doesn't send out invitations. The solar system isn't hosting a cosmic tea party where comets RSVP. So when something from another star system swings by, it's a big deal. Before 2017, we had never seen anything like that, until Oumuamua appeared, the first interstellar visitor, long and shiny and fast enough to make physicists raise their eyebrows. Then came 2I Borisov, a more comet-like traveler that at least behaved like it belonged to nature. And finally, in 2024, astronomers spotted 3IATLAS, an object that seemed to follow in those strange footsteps. Only this time, the timing and trajectory were suspiciously poetic. Think about it. For billions of years, nothing from beyond our solar system ever wandered close enough to notice. Then suddenly, in the span of a few human years, 3 of them come by? That's like living in a ghost town your whole life, and then watching 3 strangers show up at your door, asking for directions to the same place. At some point, you stop believing in coincidences and start wondering if there's a reason. What if 3IATLAS wasn't just drifting aimlessly? What if it came with intent? Good evening, curious minds. Science doesn't need to shout to be fascinating. Sometimes it's best enjoyed the way you'd enjoy a late-night conversation, quietly with a cup of tea, and maybe the soft hum of a fan in the background. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing. No pressure, only if you enjoy these calm journeys through the universe. Now, let's begin. The question sounds absurd at first, something straight out of a late-night sci-fi special, sandwiched between alien documentaries and conspiracy theories about lizard people. But here's the thing about science. Every wild discovery starts as an uncomfortable question. What if has always been the spark that leads to, wait a second, maybe. Humanity's curiosity has a bad habit of turning ordinary mysteries into existential rabbit holes. We look at the night sky and can't help but wonder if someone's looking back. And when an object like 3IATLAS crosses our path, gliding silently between planets, our brains can't help but whisper, that doesn't just look like a rock, right? Because deep down, we all want to believe that the universe is talking to us. The discovery itself was almost cinematic. Astronomers spotted it through the asteroid terrestrial impact. Last Alert System, ATLAS for short, which, let's be honest, sounds like something straight out of a superhero movie. The irony that the system's name now shares itself with an interstellar traveler is almost too perfect. It's as if the cosmos wanted to make sure we'd notice this one, like it was labeled to Earth, attention, curious species. When the data came in, 3IATLAS was already on its way out. We caught it too late to study it in detail. Just a glimpse as it sped past, headed back toward interstellar space. It was faint, fast, and oddly elusive. Astronomers could tell it came from beyond our solar system by its hyperbolic orbit, meaning it wasn't bound to the sun at all. Whatever sent it, whether chance or choice, it wasn't coming back. But that fleeting encounter was enough to set imaginations ablaze. Because if this wasn't just another random piece of cosmic debris, if there was even a tiny chance that 3IATLAS had purpose behind it, that would change everything we know about our place in the universe. Let's entertain the possibility for a second. Imagine you're part of an intelligent civilization living on a distant world. Your species has mastered interstellar travel, but rather than sending giant ships across impossible distances, you decide to send something smaller, subtler, a probe disguised as a natural object. You could hide your technology in a comet's crust, protect it from radiation, and make it look completely unremarkable. Then you set it loose into the galaxy, knowing that one day, maybe, it'll pass through someone else's home system. If they're smart enough, curious enough, and technologically advanced enough, they might notice it. And when they do, they'll ask the same question we're asking now. What if this wasn't an accident? That's the thought that keeps scientists awake at night. Not fear, but fascination. Because even if 3IATLAS turns out to be nothing more than a frozen lump of dust and ice, it's still the messenger of another sun. It's evidence that our solar system isn't isolated, that the stars really do share their leftovers. It's proof that material, and maybe messages, can cross the ocean of space. And yet, there's a haunting irony here. The moment we spotted it, it was already leaving, like a mysterious stranger who locks eyes across a crowded room, smiles, and disappears into the night before you can say hello. That's the paradox of cosmic curiosity. We are always catching the universe mid-sentence. We see the faint punctuation marks, a rock here, a comet there, but the full story remains frustratingly out of reach. Maybe that's why 3IATLAS fascinates us so much. It's not what we know about it, it's what we don't. Maybe it's just a rock that happened to wander by at the right moment. Or maybe, just maybe, it's something more. A deliberate visitor, a test, a message, or even a mirror, reflecting our own need to make sense of the chaos. Whatever it is, it left a question hanging in the cosmic air. A question humanity won't stop asking anytime soon. Because sometimes a mystery this big doesn't need an answer right away. It just needs someone willing to look up, squint into the darkness, and say, "Okay, universe, you have my attention." And so begins the story of the visitor nobody invited. But everyone will remember. If the universe had a guest book, 3IATLAS would be the scribbled signature no one saw coming. It slipped in quietly. No fireworks, no grand entrance, just a flicker of light that shouldn't have been there. Astronomers at the University of Hawaii's ATLAS project, short for Asteroid Terrestrial Impact Last Alert System, were the first to catch it in early 2024. Ironically, the system's main job is to spot asteroids that might smack into Earth. Instead, it found something far stranger. A visitor from another star. Not a threat, but a cosmic tourist passing through without even slowing down to admire the view. Now, before we get swept up in mystery, let's clarify what this thing actually is. Or rather, what it might be. When astronomers first saw it, they noticed its orbit was hyperbolic. That means it wasn't bound to the Sun at all. Everything in our solar system, from Mercury to Pluto, moves in ellipses, which are basically stretched out circles. But 3IATLAS, its orbit was open-ended, like someone flung it into space, and it just kept going. That's the cosmic equivalent of someone running through your yard, waving and never looking back. Its speed sealed the deal. Even when it was far from the Sun, 3IATLAS was moving too fast for our star's gravity to pull it back. That's how astronomers knew this thing didn't come from here. It wasn't born in the dusty nursery that built the planets. It came from out there, the interstellar void, the great in-between, where the nearest star is so far away that light takes years to cross the gap. So, what does it look like? That's the tricky part. By the time telescopes zeroed in on it, 3IATLAS was already fading, too distant and too dim for clear images. But based on its brightness and behavior, it seemed comet-like. It may have had a fuzzy tail, a faint exhale of dust and vapor triggered by sunlight. Yet, it didn't behave exactly like a normal comet. Its composition, activity, and spin pattern hinted at something different. As one astronomer put it, it's like a comet wearing a disguise, made by someone who's read about comets but never actually seen one. And that's what makes it so maddeningly rare. We've been staring at the sky for centuries, charting the dance of thousands of comets and asteroids. Yet, interstellar objects? They're practically unicorns. Before 2017, we had 0. Then, in the blink of a cosmic eye, we found 3. Oumuamua, 2I Borisov, and now 3IATLAS. It's as if the universe suddenly remembered our address and started mailing us samples. The discovery timeline itself feels like a cosmic comedy. When the ATLAS team first spotted the object, they thought it was a regular comet. It wasn't until more observations rolled in from other telescopes that the truth started to surface. The orbit didn't fit. The math said it came from outside the solar system entirely. Cue the astronomers double-checking their data, running calculations at 3 a.m., muttering things like, "That can't be right," while sipping their 5th coffee. Because when your computer tells you something is interstellar, that's the astrophysical equivalent of your toaster suddenly composing poetry. It's possible, but it makes you nervous. The moment 3IATLAS got its official 3I designation, the I standing for interstellar, it joined an exclusive club of cosmic travelers. 3I simply means it's the third one humanity has ever recorded. But behind that dry little label lies an ocean of wonder. This object has been traveling through interstellar space for possibly millions, maybe billions of years. It could have formed near another star system long before our planet even existed. Imagine that, while Earth was still a molten rock, trying to decide what kind of crust it wanted to wear, this thing was already out there, cruising between suns. Scientists estimate that interstellar wanderers like 3IATLAS are actually common in the galaxy. But spotting them is like trying to find a single grain of sand flying past a spotlight in the dark. They're tiny, fast, and rarely reflect much light. Most zip through undetected. The fact that we saw this one means our telescopes are getting sharper, our eyes to the cosmos clearer. It's like humanity finally got prescription lenses for its cosmic near-sightedness. But 3IATLAS wasn't just fast. It was on a mission-level fast. It sped through the inner solar system at tens of kilometers per second, utterly ignoring the sun's pull. Astronomers calculated that it would never return. It was just cutting through our neighborhood on a one-way trip back to interstellar space. It's hard not to anthropomorphize something that determined. It's the space equivalent of someone stopping at a gas station, checking the map, and then peeling out again before anyone can say hello. And that's where the humor of it all creeps in. Earth keeps getting these surprise cosmic visits, and each time we barely manage a, "Wait, who are you?" before they vanish. We're like the universe's worst Airbnb host. We see the guests leaving and realize, oh no, I forgot to offer snacks. What makes 3IATLAS fascinating isn't just where it came from, but what it might carry with it. Tiny dust grains and chemical fingerprints embedded in its surface could reveal what materials other star systems are made of. If scientists could have captured a sample, they might have held in their hands the literal dust of another world. But, alas, our guest didn't stick around for dinner. Instead, it left us peering into the void, running simulations and whispering, "What was that?" into the night sky. 3IATLAS reminded us how vast and interconnected the universe really is. That our solar system isn't an island, but part of a cosmic archipelago linked by unseen travelers. Every so often, something wanders through and says, "Hey, you're not alone out here." So, what's the takeaway? 3IATLAS is a mystery wrapped in ice and dust, traveling faster than anything we could build, carrying stories from stars we've never seen. Whether it's a rogue comet, a chunk of alien debris, or just maybe something more deliberate, one thing's for sure: it didn't come here by accident. It came because the universe, in all its chaotic brilliance, still loves to keep us guessing. And as far as uninvited guests go, this one didn't trash the place, though it definitely left us staring at the sky, wondering when the next knock on the cosmic door will come. Imagine checking your mailbox and finding a letter with no return address, no stamp, and handwriting you don't recognize. Yet somehow, it's postmarked from another galaxy. That's the feeling scientists get when they detect an interstellar object like 3IATLAS. It's as if the universe occasionally sends us postcards, not written in ink, but carved into rock and ice, carrying whispers from places we'll never see. When astronomers look at objects like 3IATLAS, they don't just see chunks of space debris, they see messages. Not in a literal, "Dear Earth, how's the weather" sense, but in the language of chemistry, structure, and motion. Every atom inside such a traveler tells a story about its birthplace, how its parent star formed, what kind of dust clouds swirled around it, what cosmic storms it survived before being flung into the black. In that sense, these objects are like ancient letters drifting between stars, waiting for someone curious enough to read them. For most of human history, we thought the universe was quiet, vast, yes, but silent. Our solar system felt like a sealed bubble, self-contained and separate. But interstellar visitors shattered that illusion. When something like 3IATLAS cuts through our skies, it's proof that the boundaries between star systems are more porous than we imagined. Matter doesn't stay loyal to its sun. It wanders, collides, escapes, and sometimes, if we're lucky, lands right in our telescopes. So, what do these cosmic postcards actually tell us? To answer that, think of 3IATLAS as a time capsule from a completely different neighborhood in the Milky Way. The mix of elements and ices on its surface could reveal what the chemistry was like around its parent star billions of years ago. Some stars form in metal-rich environments full of heavy elements, while others are born in more primitive regions with simpler ingredients. The ratios of carbon, nitrogen, and oxygen frozen into 3IATLAS could be a snapshot of alien weather, conditions no probe of ours has ever touched. That's why scientists go wild over even the briefest glimpse. If you can measure how a comet-like object releases gas as it warms, you can decode its past. Different ices vaporize at different temperatures. Water, methane, carbon dioxide. Each one tells a different story about how far from its original star the object formed. It's like sniffing a faint perfume in a crowd and knowing instantly where it came from. Now here's where things take a turn from science to speculation. What if these visitors aren't just accidental deliveries? What if, somewhere out there, another civilization figured out what we're only starting to suspect? That you can send information across the stars without radio signals or flashing lights. Instead of beams or messages that fade over time, they could launch physical objects, durable, passive messengers that can survive millions of years. A rock, after all, doesn't need power. It doesn't care about time. It just travels silently, carrying whatever secrets are sealed inside. If you think that sounds far-fetched, remember that we've already done something similar. In the 1970s, we attached golden records to the Voyager spacecraft, complete with instructions, maps, and greetings from Earth. That was our attempt at an interstellar postcard. A "Hi, we exist," flung into the cosmic ocean. The difference is, we used technology, but a truly advanced civilization might prefer subtlety. Why shout across the void when you can let your messages drift? So, what if 3IATLAS was one of those messages? Not a spacecraft with antennas and blinking lights, but a disguised emissary. A rock with encoded structure, layered isotopes, or an internal geometry that carries meaning. Something that only a scientifically advanced species would notice. A cosmic hello, written in the grammar of physics, not language. Think about it. A radio message can be intercepted by anyone listening. A physical one, though, could be selective. It might only be readable by those with the right instruments, knowledge, or curiosity. Maybe that's the point. Maybe civilizations capable of noticing such a thing are exactly the ones meant to find it. Like a galactic version of, if you can read this, you're ready. Of course, that's the fun part of science. The speculation that dances just outside the edge of data. So far, 3IATLAS has offered no clear sign of artifice. No signals, no unusual energy emissions, no geometric perfection. But absence of evidence isn't the same as evidence of absence. We barely had time to study it before it slipped away, taking its secrets with it. The universe doesn't often give us second chances. And yet, the idea that such messengers might exist changes how we see everything. Suddenly, comets are no longer just dirty snowballs. They're potential libraries. Asteroids aren't just rubble. They're time travelers, carrying the signatures of other worlds. The next interstellar visitor might hold fragments of molecules that hint at alien biochemistry or minerals formed in exotic conditions we can't reproduce. To scientists, that's as thrilling as finding a note in a bottle that says, "We were here." Even if 3IATLAS turns out to be purely natural, it still plays its role in the cosmic correspondence. Its journey reminds us that the galaxy is a vast ecosystem of exchange. Star systems aren't isolated. They trade material, occasionally fling out debris that drifts for eons, and sometimes, if fate allows, sends it right into the hands of another civilization, curious enough to care. That's the cosmic postcard effect in its purest form. It's the universe writing to itself, scattering fragments of story across unimaginable distances. Some are dull, some are strange, and a few, maybe, are deliberate. Each one is a reminder that space isn't empty. It's a conversation happening on scales so vast we can barely keep up. So when astronomers looked at 3IATLAS and said, "What if this came on purpose?" they weren't just indulging fantasy. They were acknowledging a truth that sits at the heart of all exploration. Every object that reaches us from beyond our world carries a question. And sometimes that question sounds a lot like curiosity itself, whispering, "Hi neighbor, nice star system you've got here." Every family has that one relative who sets impossible expectations. The overachiever who graduates early, gets all the attention, and leaves everyone else trying to live up to their reputation. In the cosmic family of interstellar visitors, that overachiever was Oumuamua when it zipped through our solar system in 2017. It was the first confirmed object from another star system ever to enter our neighborhood. It was shiny, fast, and confusing enough to send scientists and conspiracy theorists alike into a frenzy. Then, years later, along came 3IATLAS, the cooler, quieter cousin who didn't stir quite as much drama, but still made everyone squint at the sky and go, "Wait, what is that?" Oumuamua, whose name means a messenger from afar arriving first in Hawaiian, set the standard for cosmic weirdness. It wasn't just its interstellar origin that puzzled astronomers, it was its behavior. When it was first discovered by the Pan-STARRS telescope, it appeared elongated, possibly shaped like a cigar, or maybe a pancake. The data was ambiguous, and every telescope that tried to catch a better glimpse found it already too faint. It was like trying to take a photo of a celebrity running through fog. What truly made Oumuamua a household name? Well, at least among people who keep telescopes in their households, was how it moved. After passing near the sun, it accelerated slightly more than gravity alone could explain. That extra push was subtle but undeniable. Usually, comets do this when sunlight heats their icy surfaces, releasing gas that acts like a tiny thruster. But Oumuamua showed no visible tail, no puff of vapor, no glow of escaping gas. It was accelerating without a clear reason, as if something or someone had given it a little cosmic nudge. Cue the theories. Some scientists proposed that it was a fragment of nitrogen ice, chipped off a Pluto-like world in another star system. Others thought it could be a sheet of hydrogen ice, sublimating in ways we couldn't detect. But then came the wilder suggestion. What if Oumuamua was artificial, a solar sail or probe sent by an alien civilization? Avi Loeb, a Harvard astrophysicist, made that argument publicly, sparking a media storm. Overnight, Oumuamua became the rock that launched 1,000 headlines. It was the first interstellar visitor, and possibly, just maybe, an alien artifact. Now, fast forward a few years. Enter 3IATLAS, cruising into our solar system with far less dramatic flair. Compared to Oumuamua's cinematic entrance, Atlas was almost polite. It didn't change speed mysteriously, it didn't glint oddly, and it didn't leave astronomers questioning their sanity. Yet, the timing of its arrival, just a few years after Oumuamua and 2I Borisov, was enough to raise eyebrows. 3 interstellar guests in under a decade, after billions of years of silence? That's statistically like finding 3 four-leaf clovers in a row and pretending it's business as usual. In terms of physical characteristics, the two objects are like night and day. Oumuamua was reflective and elongated, estimated to be somewhere between a few dozen and a few hundred meters long. 3IATLAS, on the other hand, seemed more comet-like, fuzzy, diffuse, and possibly breaking apart as it passed near the sun. Where Oumuamua was a mysterious shard of something, Atlas looked more like a traveler that had been on the road too long and was falling apart from exhaustion. If Oumuamua was a sleek sports car speeding through space, 3IATLAS was the battered station wagon trailing smoke. Still, the comparison between them is irresistible. They're both unbound by the sun's gravity, both on hyperbolic trajectories that will carry them back into interstellar darkness, and both made of materials foreign to our solar system. But while Oumuamua inspired speculation about alien technology, 3IATLAS leaned more toward the old-fashioned cosmic ice cube category. That didn't make it less fascinating. It just meant that this cousin preferred subtlety over spectacle. Some astronomers joked that Oumuamua crawled so 3IATLAS could coast. The first paved the way, forcing us to invent new ways of thinking about what's possible, while the second came along to remind us that interstellar visitors aren't just one-time wonders. They might actually be common. Maybe the galaxy is full of these travelers, each carrying its own story, and we've only just learned to notice them. There's also a poetic symmetry in how the two were discovered. Oumuamua was found in Hawaii by Pan-STARRS. 3IATLAS was also found in Hawaii by a different telescope system named ATLAS. It's as if the islands, born from volcanic fire and surrounded by ocean, are perfectly symbolic discovery points for interstellar drifters crossing the cosmic sea. The sky above Hawaii, it seems, is where the universe chooses to drop its cosmic mail. Yet, beyond their differences, what connects Oumuamua and 3IATLAS is the way they changed how we think about our cosmic neighborhood. Before 2017, interstellar objects were mostly theoretical, a maybe someday topic in astronomy textbooks. After Oumuamua and its cousins, they became real, tangible, fleeting, yes, but undeniably here. They proved that material from distant stars doesn't just stay put. It travels, carrying the fingerprints of alien systems, and sometimes, just maybe, a bit of their mystery. And that's the beauty of it. Oumuamua's weirdness cracked open the door of possibility, and 3IATLAS quietly walked through it. Together, they form a kind of 1-2 punch of discovery. The first saying, "Look, the galaxy is full of surprises," and the second replying, "And we've only started to notice them." Of course, comparing them also highlights how much we still don't know. We never got close enough to either to study them in detail. Both appeared suddenly, sped past at tens of kilometers per second, and were gone before we could launch any probe. They're like cosmic celebrities, making brief red carpet appearances before vanishing into the night. All we have are a few snapshots, some faint data points, and a mountain of questions. But that's what makes them so thrilling. They remind us that our solar system isn't isolated. It's a rest stop on a galactic highway. And every now and then, someone or something passes through. Some arrive blazing, like Oumuamua, demanding attention. Others, like 3IATLAS, drift by quietly, as if observing from afar. In the end, they're both part of the same larger story, the story of how the universe trades its secrets. Oumuamua may have been the loud, older sibling, the one that made headlines and arguments, but 3IATLAS showed up to prove the phenomenon was real. And together, they've taught us that the cosmos isn't just a backdrop of stars. It's alive with travelers, each one carrying a story we can't yet read. Because in the family of interstellar visitors, drama seems to run in the dust. Let's get one thing straight. Space is huge. Not, wow, that's big, huge. More like, if you printed a map of it, you'd run out of universe before paper. Huge. Stars are so far apart that if the sun were the size of a beach ball, the next nearest star would be another beach ball sitting in Paris, while you're holding yours in New York. Now, imagine tossing a single grain of sand from that New York beach and having it accidentally land in the palm of someone standing in Paris. That's roughly the level of coincidence we're talking about when something from another star system, like 3IATLAS, happens to pass right through ours. In a universe this vast, the odds of an interstellar object just randomly drifting into our small solar neighborhood are mind-bendingly tiny. Yet, it's happened not once, but 3 times in the past few years. Either the cosmos has decided to start a delivery service, or there's something we're missing about how these wanderers find us. Astronomers have a way of calculating probabilities that makes you question whether chance even exists. They can estimate how much material each star ejects into space. Rocks, comets, icy leftovers, and how fast those fragments travel through the galaxy. Multiply that by the number of stars in the Milky Way, which, spoiler alert, is roughly 100 billion. And you get a cosmic soup of debris. Even then, the space between stars is so staggeringly empty that most of that debris will never come close to anything. So, when one of these travelers, say 3IATLAS, just happens to glide through the narrow band of space our telescopes are watching, it's statistically equivalent to winning the lottery 3 times in a row without buying a ticket. You can see why some scientists raise an eyebrow and whisper, "Really? 3 interstellar visitors already?" Of course, probabilities are tricky things. They don't prevent rare events. They just make them rare. Flip a coin enough times, and you'll eventually get 20 heads in a row. But if you get those 20 heads in your first 20 flips, you can't help feeling like the universe is winking at you. That's where 3IATLAS sits, at the uncomfortable intersection of coincidence and curiosity. To appreciate just how improbable its visit is, we need to peek, gently, into orbital dynamics. Don't worry, no equations here. Picture the solar system as a vast racetrack, with planets orbiting neatly around the sun. Most comets and asteroids that enter this racetrack are bound to it. They loop around the sun, maybe crossing paths with Earth, and then swing back again. But interstellar objects like 3IATLAS don't loop. They zoom straight through the track, coming from somewhere far beyond the starting line and exiting before the race even begins. For that to happen, its speed and trajectory have to be just right. Too slow, and it would get trapped by the sun's gravity, becoming another long-term resident. Too fast, and it would miss the solar system entirely. To intersect with us at all, it must thread a cosmic needle, arriving at precisely the right time and angle. Imagine throwing a dart from the edge of the solar system and hitting a target smaller than a planet's orbit, blindfolded, while spinning. That's the level of precision we're dealing with. And yet, that's exactly what 3IATLAS did. Now, of course, nature can be generous with coincidences when you have enough time. The galaxy has been around for over 13 billion years, and our solar system's been cruising through it for more than 4.5 billion of those. In all that time, trillions of interstellar objects have probably passed nearby. We just didn't have the eyes to see them. Modern telescopes like ATLAS and Pan-STARRS are finally sensitive enough to spot the faint streaks of light that betray their presence. So perhaps the odds aren't as impossible as they sound. Maybe the cosmic dice have been rolling this way all along. We've only just learned how to notice. Still, there's something about the timing that feels peculiar. The first interstellar visitor, Oumuamua, was discovered in 2017. Then, 2 years later, came 2I Borisov, then 3IATLAS in 2024. For billions of years, nothing, then 3 in less than a decade. It's the celestial equivalent of hearing a knock on your door after a lifetime of silence, and then getting 2 more knocks before you've even reached the handle. Coincidence? Possibly. But it's hard to ignore how convenient it is that these visits align with the era when humanity finally has the technology to notice them. Maybe it's pure chance. Maybe the universe has always been flinging stones our way, and we're just now catching them mid-flight. Or maybe, and this is where the imagination starts humming, the timing isn't random at all. Maybe we're being visited now because this is the moment when we're finally capable of understanding what we're seeing. Scientists, ever cautious, lean toward the "we're just noticing more" explanation. After all, there's a vast difference between impossible and unlikely. The odds might be microscopic, but given enough cosmic lottery tickets, someone's bound to win. Still, even the most grounded astronomers can't resist the poetic appeal of the alternative, that maybe the universe chose this moment to send us a few visitors. There's a saying among astrophysicists: the universe is under no obligation to make sense to you, and yet, sometimes, it almost does. The pattern of these arrivals feels deliberate, like someone tapping Morse code across the stars. Dot, dash, pause. 3IATLAS might just be another dot in that sequence, another punctuation mark in a story we're only beginning to read. Of course, if you tell a statistician that, they'll roll their eyes and remind you that patterns are what human brains do best, especially when there aren't any. We find meaning in randomness because that's how our ancestors survived. We see shapes in clouds, faces in toast, and purpose in comets. But deep down, that curiosity is what drives science forward. Every impossible coincidence we chase eventually becomes an explanation waiting to be discovered. So maybe the odds are astronomically small. Maybe we just got lucky. But maybe, just maybe, luck isn't the right word. Because in a universe filled with endless possibilities, even the rarest encounters are bound to happen somewhere, sometime. And this time, it just happened to be here. After all, as one astronomer joked, the odds of this being random are so small, it's like flipping a coin and getting a galaxy. And wouldn't you know it, we just might have done exactly that. If aliens ever decided to reach out, they probably wouldn't start by hijacking our TV signals or sending crop circle invitations. They'd know better than to beam, "Hey there, neighbors," across hundreds of light years, only to have the message arrive centuries late and possibly mid-commercial break. No, if an intelligent civilization truly wanted to say hello across the cosmic void, they'd have to get creative, patient, subtle, and just a little bit sneaky. That's where the idea of interstellar messengers comes in. Forget glowing saucers or little green diplomats shaking hands with presidents. Think small, think efficient, think durable. Because when you're dealing with distances so absurdly vast that even light feels sluggish, sometimes the simplest solution is also the smartest. As one astrophysicist quipped, if aliens wanted to avoid long-distance charges, sending a rock is cheaper than a phone call. The problem with most forms of communication is that space doesn't care about your signal strength. Radio waves disperse, photons fade, and every passing dust particle or magnetic field can distort a message until it's as intelligible as static. Sure, radio signals travel fast, at the speed of light, but they also weaken dramatically as they spread. A beam sent from another star would arrive at Earth whisper soft, lost among the cosmic background noise. If you want to send something across the galaxy that's guaranteed to survive the journey, you don't use light. You use matter. That's where probes come in. We've already dabbled in this idea ourselves with Voyager and Pioneer, two spacecraft now drifting beyond the edges of the solar system. They carry plaques and records, little artifacts of humanity in case someone out there finds them. But if you're an advanced civilization, thinking on the scale of millennia or even eons, you might skip the flashy technology altogether and choose something that looks utterly ordinary: a rock. Imagine engineering a small probe encased in layers of natural-looking material. designed to mimic a comet or asteroid perfectly. From the outside, it's indistinguishable from the countless chunks of ice and dust tumbling through space. Inside, however, it's a treasure trove of information. Encoded patterns, microscopic structures, or even self-replicating nanomachines, ready to awaken when they detect the right conditions. It's the interstellar equivalent of hiding a letter inside a snowball and tossing it across the galaxy. Such an object could survive cosmic radiation, impacts, and unimaginable time spans. It wouldn't need power or guidance systems. It would simply drift until it found a star system worth investigating. Maybe that's exactly what 3IATLAS was. A cleverly disguised ambassador wearing a comet's coat. We might not even recognize it as artificial unless we were able to catch it mid-journey and crack it open. Now, if our hypothetical aliens are more the engineer type, they might go for something fancier, a light sail. Picture an enormous, ultra-thin sheet of reflective material propelled by the pressure of starlight itself. We've already tested the concept with projects like Breakthrough Starshot, which envisions sending gram-sized probes to nearby stars using laser propulsion. A civilization, even a few centuries ahead of us, could launch fleets of these tiny explorers, each one capable of crossing interstellar space without fuel. To us, one of these sails might look like a shard of metal or a strange flash of light glinting against the stars. If that sounds familiar, it should. Oumuamua's strange acceleration once led scientists to wonder if it was exactly that, a light sail drifting through space. While there's no solid proof, the idea refuses to die because it makes an elegant kind of sense. Why spend the energy to send messages when you can send durable, self-contained explorers that double as calling cards? It's slow communication, yes, but across the stars, patience is a currency that advanced species probably have in abundance. Another possibility is that aliens might not be trying to communicate at all, at least not in a way we'd recognize. They might simply be scattering probes everywhere, an automated expansion of curiosity. Like cosmic dandelions, they release seeds into the wind, letting the universe decide where they land. Some probes might collect data, others might just observe silently. Maybe one drifted into our solar system, took a quick peek, and then slipped away before we even noticed. And if you think this sounds too fanciful, consider what humanity is already doing on a small scale. We've launched robots to Mars, the outer planets, and beyond. We're experimenting with miniature interstellar concepts. We even discussed the possibility of storing DNA or digital consciousness on future probes, turning them into literal carriers of life. Give us another 1,000 years, and who's to say our own descendants won't be the aliens sending disguised messengers to other worlds? So, if a civilization somewhere out there has had a head start of a few million years, and in cosmic terms, that's just being a little early to the party, they'd have plenty of time to perfect the art of subtle contact. Their goal might not be dramatic arrival scenes or cinematic communication. It might be to test us, to see if we're observant enough to recognize the difference between random rock and deliberate messenger. After all, the first step in saying hello might be finding out who's paying attention. And that's the genius of the rock method. No risk, no energy cost, no cultural contamination. Just toss a message into the cosmic current and let probability do the rest. If it never gets found, no harm done. If it does, and the finders are curious enough to decode it, congratulations, they've passed the intelligence test. It's the galactic version of slipping a note under someone's door with no name attached and seeing who figures out it's for them. Of course, none of this proves that 3IATLAS or any interstellar visitor was a message in disguise. But the mere possibility reframes how we look at the sky. Every comet, every asteroid, every flicker of light could be more than just a rock. It could be a hello written in matter, drifting through eternity. And if that's the case, then maybe the cosmos isn't as silent as it seems. Maybe it's just using the slowest, most reliable postal service imaginable, one rock at a time. If James Bond were a space probe, this would be his ice-covered tuxedo, sleek, unassuming, and perfectly dressed for infiltration. That's one way to imagine 3IATLAS, a secret agent of the stars, wrapped in layers of cosmic camouflage, drifting across the galaxy under the perfect disguise, a comet. Let's play with that idea for a moment. Suppose you're an advanced civilization trying to explore or even observe other worlds. You want to send a probe across interstellar space. But there's a catch. The galaxy is a hostile environment. It's full of radiation, charged particles, and micrometeorites zipping by at deadly speeds. You can't exactly hide behind a star to dodge danger. You need something durable, something stealthy, something that won't draw attention from the locals. Enter the perfect disguise, the cometary shell. A comet is one of nature's most efficient shields. Its outer layers are packed with ice, dust, and organic compounds that act like cosmic armor. Underneath that frosty crust, a probe could sleep for millions of years, safe from radiation and temperature extremes. It's like encasing a secret in an indestructible snow globe. When sunlight finally touches it, that ice vaporizes, creating the familiar cometary tail, a natural phenomenon so common that no one would suspect it was hiding something. The brilliance of this camouflage is that it plays on human assumptions. When astronomers see a fuzzy, icy object swooping through the inner solar system, they instantly categorize it as a comet. It's almost reflexive. That mental shortcut, our tendency to classify before questioning, is exactly what a disguise probe would exploit. Why hide in the shadows when you can hide in plain sight? To understand why this disguise works so well, it helps to picture what interstellar travel does to an object. Space between stars isn't empty. It's filled with high-energy particles, cosmic rays, and stray debris. Over millions of years, These forces can erode or sterilize anything unprotected. A metal spacecraft would be scarred beyond recognition. Its electronics would fry unless shielded by several meters of dense material. But if you embed your probe inside a thick shell of ice and rock, it's like slipping into a cosmic sleeping bag. The radiation might chip away at the surface, but the core remains untouched. And what about detection? Humans are good at spotting things that stand out. Bright metal reflections, unnatural shapes, or heat emissions would catch our telescope's attention. But comets? We've catalogued thousands. Most of them are dull, cold, and irregular. Exactly what a spy probe would want to look like. Even the occasional odd trajectory wouldn't raise suspicion because comets are unpredictable by nature. Their surfaces crack, outgassing jets shift their motion, and some disintegrate entirely. It's chaos, and in chaos, there's perfect cover. Let's take it further. Suppose the outer layer isn't just natural ice, it's engineered. Perhaps the ice is a composite of frozen gases and nanomaterials designed to mimic natural reflectivity while providing superior insulation. The dust layer could contain microscopic filaments that absorb radar or scatter light in ways that confuse scanners. It would look exactly like a comet to any human telescope, but it could hide an intricate core of alien machinery inside. A sensor array, a data capsule, or something we can't even imagine. And how would it operate? Not with thrusters or antennas that give it away, but passively. It could drift silently until it encounters a target of interest, using gravitational nudges to adjust its path. Inside, it might store a small autonomous intelligence, awakening only when conditions meet specific criteria, say the detection of artificial radio signals or a nearby planet emitting oxygen. Then it could briefly activate, gather information, and go dormant again. No energy wasted, no signal leaked, just stealth perfected. Of course, this is speculation of the highest order, but it's the kind that tickles scientists because it forces us to consider what possible really means. After all, if we can imagine such a strategy, a civilization millions of years older than ours could probably build it before breakfast. We already use stealth coatings, radiation shielding, and cryogenic storage on our own spacecraft. Scale that up with alien-level technology, and a disguised probe suddenly feels less like science fiction and more like good engineering. The idea of cosmic camouflage also explains one of the greatest mysteries of interstellar visitors: their fleeting, frustrating appearances. They show up. We notice them too late to study them closely, and then they're gone forever. Maybe that's intentional. A true stealth probe wouldn't linger near its target. It would pass through quickly, collecting just enough data to remain unnoticed. The perfect spy doesn't need to stay. It just needs to see. It's also possible that such an object could hide even after being detected. Imagine if, upon realizing it's being watched, the probe subtly altered its behavior, shifting its spin, dimming its reflectivity, or shedding fragments to confuse observers. To us, it would look like a comet naturally breaking apart. To it, it's a tactical retreat. Naturally, there's no evidence that 3IATLAS or any interstellar visitor is actually playing cosmic secret agent. Every observation we have fits comfortably within the realm of physics and chemistry. But the elegance of the disguise is that we wouldn't know. That's the beauty and frustration of perfect camouflage. If nothing else, thinking of 3IATLAS as a stealth probe forces us to see comets in a new light. They're not just pretty trails of ice and dust. They're reminders of how adaptable the laws of physics can be. Whether natural or engineered, the cometary form is a masterpiece of endurance, a shape built to survive radiation, temperature swings, and the endless emptiness between stars. So maybe, just maybe, every comet we see is more than just an icy wanderer. Maybe some of them are wearing tuxedos of their own, silent observers wrapped in glittering disguise, gliding through the void with secrets buried beneath the frost. After all, if you were trying to blend into the cosmos, why not dress like one of its most ordinary citizens? The best spies always look like they belong. If you've ever played billiards, you know the satisfaction of banking a shot just right, sending the cue ball ricocheting off 1, 2, maybe 3 cushions before it lands exactly where you wanted. Now imagine doing that in space, except the table is a few trillion miles wide, the cushions are stars, and your cue ball is a frozen rock traveling faster than anything humans have ever built. Welcome to the wild physics of interstellar navigation, or, as I like to call it, space billiards, but with a trillion-mile table and no one yelling, 8 ball in the corner. If an intelligent civilization wanted to send something like 3IATLAS our way on purpose, they'd have to master this cosmic game. Getting from one star to another isn't just about brute force. You can't simply point a probe toward a target and hit the gas. It's not a road trip. The distances are mind-breaking, and every ounce of fuel counts. So, smart travelers would take advantage of something the universe offers for free: gravity. Here's how it works, without the math headache. Every planet and star has gravity, a kind of invisible hand pulling everything toward it. If you swing a spacecraft close enough, that hand can slingshot you forward, giving you a boost of speed without burning fuel. It's called a gravitational assist, and we already use it all the time. NASA's Voyager probes, for example, got their cosmic speed boosts by whipping around Jupiter and Saturn. Those flybys gave them the momentum to escape the sun's grip entirely, turning them into the first human-made objects to enter interstellar space. Now, imagine scaling that trick up to an interstellar level. A civilization that truly understands gravity could chart a course through the galaxy, using a series of stellar flybys, each one bending their object's path just enough to redirect it toward the next target. Like a cosmic pool player, They'd calculate every angle, every nudge, and every flick of motion until the final shot lands right in our solar system. Of course, pulling that off isn't just difficult, it's insane. The precision required would make even the best astrophysicist sweat. You'd have to account for not just planets, but the movement of entire star systems, which drift through space at tens of kilometers per second. Aiming at Earth from another star would be like trying to hit a moving grain of sand from billions of miles away while blindfolded, and throwing the dart 1,000 years before the target even exists. But here's where things get interesting. For all its complexity, this kind of navigation might actually be possible if you've got time, and lots of it. A civilization millions of years older than ours could easily afford to think in slow motion. They might launch an object that takes thousands of years to reach us, using the gravity of multiple stars to guide its path. Each encounter would subtly alter its velocity, shaving off errors until the final trajectory aligns perfectly with our solar system. In that sense, 3IATLAS could be the end of a very long, very deliberate journey. Not a random fling, but the final bounce in a galactic trick shot, planned long before humans ever looked up. To make such a mission work, the object wouldn't even need active engines. Gravity would do the heavy lifting. A few initial nudges from its launch system, say a gravitational catapult or light sail, would set it in motion. After that, the galaxy itself becomes the steering mechanism. It's like curling, but on a cosmic scale. Launch once, glide forever, and hope your math is flawless. Now, why choose gravity as a navigation tool at all? Because it's efficient, elegant, and, most importantly, undetectable. A craft using propulsion might leave signatures, heat, radiation, or light. But one coasting on gravity looks indistinguishable from a natural object. It's stealthy by design, blending into the crowd of comets and asteroids. It's the perfect way to send something across the stars without announcing its presence. Let's pause for a reality check. Even with advanced technology, plotting a gravitational trajectory to Earth would be unimaginably complex. The galaxy is a moving target, and so are we. The Sun orbits the Milky Way at about 500,000 miles per hour, dragging all its planets along for the ride. By the time a probe launched from another star reached us, our solar system would have moved light years from its starting position. Predicting that far ahead requires a mastery of celestial mechanics we can barely comprehend. But again, impossible doesn't mean impossible forever. Humans have already begun exploring this realm of physics, just on smaller scales. When we send missions to Jupiter or Neptune, we rely on precisely timed flybys calculated decades in advance. We already surf gravity for free speed boosts. It's not hard to imagine a species thousands of years ahead of us doing the same thing across interstellar distances. And maybe that's the most compelling part of this whole idea. The physics itself doesn't forbid it. It's not magic. It's just math, patience, and and precision. A carefully orchestrated series of slingshots could send an object like 3IATLAS coasting through the stars, eventually intersecting with Earth's orbit as if by coincidence. To us, it looks random. To its creators, it's the result of a perfectly played game of galactic billiards. If that's true, if some distant intelligence did aim this thing at us, it means they've been planning longer than we've been walking upright. Their sense of time must be so vast that a million-year journey feels like dropping off a postcard next door. It's humbling and a little eerie to think about. Of course, there's still every chance 3IATLAS was just a natural traveler, caught in the sun's gravity by pure luck. But every time scientists map out its orbit, watching how it curved and coasted through our planetary system, they can't help but marvel at how perfectly it fit the path. Sometimes, a trajectory looks so purposeful, you can't help wondering if there's a cue stick somewhere behind it. So maybe it was all coincidence, or maybe somewhere in a faraway star system, an alien physicist is leaning back, grinning smugly, and saying, "Told you I could make that shot." If there's one thing astronomers have learned from decades of chasing cosmic mysteries, it's that space loves to mess with expectations. You think you're studying a rock, and suddenly it starts behaving like it's auditioning for a sci-fi movie. That's why, when something like 3IATLAS swings by, the first question isn't just what it is, but how it behaves. Because behavior, motion, spin, light reflection, energy output, is where nature and technology begin to look different. And if 3IATLAS had any secrets of design hidden in its frozen shell, they would have been revealed not by what it looked like, but by how it moved. Unfortunately, it ghosted us faster than a bad Tinder date. Seriously. By the time telescopes locked onto 3IATLAS, it was already halfway out the door, fading fast and leaving only whispers of data behind. But even those whispers were enough to spark the question, was there anything about its behavior that hinted at artificiality? To understand what scientists look for, imagine you're trying to tell the difference between a bird and a drone in the sky. At a glance, both might glide, dip, and shimmer in sunlight. But the drone moves with mechanical precision. Its turns are calculated, its flight path deliberate. A bird, on the other hand, moves with the messy chaos of nature. That's exactly the distinction astronomers are searching for in interstellar visitors. Patterns too neat, too engineered to be random. The first clue would be motion. Natural objects follow predictable rules. They're guided by gravity, inertia, and the occasional shove from sunlight or outgassing. If something suddenly speeds up or shifts direction without an obvious cause, eyebrows go up. That's what made Oumuamua such a head-scratcher. It gained extra velocity as it left the sun, even though it didn't display the usual cometary tail that could explain it. Scientists considered possibilities ranging from hydrogen sublimation to exotic ices, but none quite fit neatly. A non-gravitational push without a clear source always smells a bit intentional. For 3IATLAS, astronomers watched carefully for any similar anomalies. Did it accelerate oddly? Did its spin rate change in ways nature couldn't explain? From what little data we have, it behaved mostly like a comet. Faint outgassing, a fuzzy coma, a trajectory that obeyed gravity. But the absence of anomalies doesn't mean absence of mystery. It just means the object didn't hang around long enough for us to catch it misbehaving. Next comes rotation. Every asteroid and comet spins, but they spin in their own chaotic ways, tumbling, wobbling, slowing down as jets of gas push against them. But a precisely controlled rotation, one that stays perfectly stable or changes at mathematically regular intervals, might hint at internal mechanisms. It would be like finding a rock in your backyard that hums in tune with a metronome. In space, uniform rotation often screams engineered stability. Scientists tried to measure 3IATLAS's spin by tracking how its brightness fluctuated as it rotated. The flicker pattern, called a light curve, can reveal shape and rotation speed. Sadly, the signal was faint and fleeting, and what little they could capture looked like a natural object's light curve. Irregular, erratic, inconsistent. If there was a rhythm hiding in the data, it drowned in cosmic noise. Then there's the question of reflectivity. Artificial surfaces tend to reflect light differently from natural ones. A metal or composite material could produce glints, sharp, mirror-like flashes that stand out against the dull, dusty glow of a comet. Oumuamua famously exhibited unusual brightness variations, which some interpreted as a sign it might be flat, perhaps even sail-like. But 3IATLAS was too diffuse, too dim. Its reflectivity fit comfortably in the probably covered in space grime category. If it had any metallic gleam, it was buried under layers of ice and dust, thick enough to fool even the most suspicious telescope. Energy emissions are another giveaway. A powered craft, no matter how advanced, would leave thermal or electromagnetic traces. Heat signatures, radiation bursts, or radio noise. So far, every interstellar visitor has been silent on all frequencies. No radio chatter, no thermal excess, no strange blips. The universe, it seems, prefers the quiet type. Still, silence isn't proof of nature. An engineered object could be designed not to emit anything detectable. Think of it as the ultimate stealth mode. No engines, no beacons, no signs of life. It could even use our sun's heat to power minimal systems, hiding its operations in the same infrared glow as the solar wind. To us, it would look indistinguishable from a natural body. Just another dusty ice ball doing its cosmic commute. But here's where things get philosophical. What if artificial design doesn't look artificial at all? We tend to imagine alien technology as shiny and symmetrical, filled with blinking lights and right angles. But why would another civilization think the same way? Their technology might grow instead of being built. It could evolve organically, forming shapes that mimic natural structures. A probe that looks like a rock might be a rock, repurposed by something intelligent to carry information, like a coral shell turned into a transmitter. If that's the case, we might have already seen thousands of alien designs and simply filed them under asteroid, probably unremarkable. That's the cruel irony of cosmic archaeology. We can't always tell what's natural and what's intentional. The line between geology and engineering blurs when you zoom out far enough. Every rock, after all, is shaped by physics, and physics itself might be the ultimate designer. In the case of 3IATLAS, all we can say for sure is that it looked natural, behaved natural, and departed before we could be certain either way. We pointed telescopes, collected spectra, compared models, and just as the questions got interesting, poof, gone. Like a magician's final flourish, it vanished into the darkness, leaving scientists holding empty notebooks and half-finished theories. Maybe it was nothing more than frozen dust. Or maybe, just maybe, it was something more deliberate. A silent visitor, wearing the perfect disguise, content to let us wonder forever. Either way, its exit was pure cosmic style. It didn't explode, linger, or crash dramatically. It just glided away, fading into the black. No goodbyes, no forwarding address. And that's how 3IATLAS earned its reputation. Not as proof of aliens or evidence of nature's genius, but as the ultimate mystery guest. The one who showed up, dropped a few hints, and disappeared before the party got started. A reminder that in the vastness of space, even silence has a story to tell. And sometimes that story is more intriguing than any signal could ever be. If 3IATLAS really was sent here on purpose, then we're left with the biggest question of all, the one that drives every science fiction story, every late-night telescope vigil, every hopeful search for a signal in the static. Why? What could possibly motivate a civilization light years away to hurl a frozen, silent messenger across the galaxy toward our little blue dot? Let's assume for a moment that it wasn't just a rock, but a deliberate visitor, an emissary of something intelligent, calculated, and watchful. If so, there are a few possibilities, and each one says something not just about them, but about us. The first and most optimistic theory: curiosity. Maybe the beings who sent it are just like us in one fundamental way. They want to know what's out there. Maybe curiosity isn't just a human thing. It might be a galactic side effect. After all, curiosity is evolution's favorite trick. On Earth, it's what led a few clever apes to start poking sticks into termite mounds, lighting campfires, and eventually strapping rockets to themselves. Curiosity is how life learns, how intelligence spreads. It's entirely plausible that somewhere else, another species followed that same pattern of, what happens if I? Until they were exploring the stars. From that perspective, 3IATLAS could simply be a scientific expedition, a probe designed to gather data about alien star systems. Not to communicate, not to interfere, but to observe. If so, it might be carrying instruments to measure planetary atmospheres, magnetic fields, or traces of life. To them, we might just be another data point on a long list of curiosities. Picture an alien lab where scientists peer at holographic projections of planetary systems the way we study microscope slides. One of them points at a speck labeled Sol 3 and says, "Hey, that one's got oxygen. Send one of the rocks that way." It's not malice, not contact, just research, the cosmic equivalent of bird watching. But then again, maybe their motive isn't curiosity, it's caution. Think about how we behave when exploring dangerous places. When humans first sent probes to Venus or Mars, we didn't go ourselves. We sent machines, small, expendable scouts, to test the environment before committing to anything riskier. We wanted to make sure it was safe, or at least predictable. Perhaps that's what 3IATLAS represents, a cautious first step, a test to see whether anyone out here is paying attention. If we notice, that tells them something. If we don't, that tells them something else. It's a non-verbal conversation, played out through silence and motion. They might be watching to see if we react, if we scan, if we send signals back. It's the universal version of gently knocking on a door and waiting to see who answers, or whether anyone's home at all. And what if it's not about us specifically, but about timing? Maybe the senders have a policy. Only approach civilizations that have reached a certain level of awareness. Sending a probe disguised as a comet could be a kind of intelligence filter. If a planet's inhabitants notice its peculiar orbit, analyze it, and wonder if it's artificial, they've proven themselves ready for the next phase. If they dismiss it as just another rock, they're not ready yet. It's less a message, more an exam. This idea that we might be tested without knowing it is both thrilling and unsettling. Because if we pass, what happens next? Do we get another visit, a signal, or simply silence again? But this time, deliberate silence. The kind that says, "We see you, we're thinking." Then there's another darker possibility. Maybe it's not about us at all. Maybe 3IATLAS was sent long ago as part of an automated survey, one of countless probes dispatched to chart the galaxy. To its creators, we're just the next entry in a cosmic database, a planet with a promising chemical signature but no need for contact. To them, we're background noise. That thought is humbling. The idea that we might have been studied, categorized, and quietly ignored before we ever realized what was happening. But if the motive were truly caution, it could also mean they're afraid. Not of us specifically, but of what lies in the unknown. Maybe they've learned, through experience, that the universe can be unpredictable, even hostile. Sending uncrewed probes could be their way of exploring without exposure, Imagine an ancient civilization scarred by some cosmic catastrophe, a war, a rogue AI, a natural disaster. They might still crave discovery, but not risk. Their probes could be survivors in exile, drifting reminders of a civilization that doesn't dare step into the spotlight again. Still, there's one more possibility that deserves attention: the teaching motive. Perhaps the act of sending these objects isn't about data or safety at all, but about inspiring curiosity in others. Maybe the goal was never to communicate directly, but to provoke thought, to make us look up and wonder, because wonder, after all, is the first step toward connection. If that's true, then it's working. Every time one of these interstellar visitors glides past, it lights a fire in our collective imagination. Scientists debate, philosophers ponder, dreamers speculate. Whether intentional or not, 3IATLAS made humanity ask, what if? And that's a question that always leads somewhere new. Perhaps curiosity and caution aren't opposites, but companions. The universe may favor civilizations that balance both. The ones brave enough to explore, but wise enough to stay quiet. Maybe we're all part of that dance, separated by light years yet driven by the same cosmic impulse, to reach out without shouting, to learn without being seen. So if 3IATLAS was a message, maybe it wasn't saying we're here. Maybe it was whispering, are you ready to listen? And maybe, just maybe, that's the most universal greeting there is. We've been dropping interstellar business cards since the 70s. Maybe someone finally picked one up. Before we start wondering whether 3IATLAS was a message sent to us, it's worth remembering that we've already been sending messages out there for decades. Some intentional, others accidental, all deeply human. The irony is that while we search the skies for signs of intelligence, we've already mailed our own return address to the cosmos, complete with music, math, and a map pointing right back to home. It started with optimism. In the early 1970s, humanity decided to do something audaciously simple: carve a message into metal and fling it into space. The Pioneer, the 10 and 11 missions each carried an aluminum plaque engraved with a few basic illustrations: a man and a woman, a diagram of the solar system, and a pulsar map showing our location. It was our cosmic hello, designed by astronomer Carl Sagan and artist Linda Saltzman-Sagan. The idea was that if an alien civilization ever found one of these spacecraft drifting through space, they'd have at least a few clues about who sent it. It was charmingly naive and beautifully brave. After all, we had no idea if anyone would ever see it, or if they'd even interpret it correctly. The plaque showed two humans, one with a raised hand, as if waving. We hoped it would be read as a gesture of friendliness, but who knows? Maybe it looks like a challenge in someone else's body language. Maybe they think the man's holding up a stop sign. Then came Voyager 1 and 2, the grand tour of the outer planets and, eventually, the stars. Each carried a more elaborate message, the Golden Record. This was no simple plaque. It was a time capsule, a mixtape for the universe. On it were sounds of Earth, waves crashing, birds singing, a baby crying, greetings in dozens of languages, and music ranging from Bach to Chuck Berry. We even included the sound of a kiss. Somewhere out there, in the frozen dark, two spacecraft are hurtling toward infinity, each carrying a gold-plated record of who we were at the moment we dared to say hello. And that's the poetic part. We said hello before anyone ever answered. We didn't wait for an invitation. We just sent ourselves. Voyager 1 is now over 24 billion kilometers from Earth, beyond the influence of our sun's magnetic bubble. It's technically interstellar now, our first true emissary to the galaxy. Voyager 2 isn't far behind. They're both still whispering faint signals home, weaker than the flicker of a candle seen from Jupiter. Each bit of data they send is a heartbeat, a reminder that, for all our flaws, humanity's greatest instinct has always been to reach outward. But here's where it gets fascinating. We never launched these probes expecting a reply. The odds of anyone ever finding them are infinitesimal. The galaxy is vast, and the spacecraft are tiny, smaller than a bus, tumbling through endless darkness. It's like tossing a message in a bottle into an ocean that spans billions of light years. And yet, we did it anyway. Not because it was practical, but because it felt right. There's something deeply telling about that impulse. We wanted to be known, even if no one was listening. We wanted to tell the universe, we exist, and this is what it's like to be us. Maybe that's the real definition of intelligence. Not just the ability to build technology, but the urge to announce yourself to the void. In a way, our probes are our own form of cosmic breadcrumbs, tracing a faint trail of humanity's curiosity across space. The Pioneer and Voyager missions paved the way for others. New Horizons, for instance, which flew past Pluto in 2015 and is now on its own slow journey into interstellar space. While it doesn't carry an engraved map or a record, it still bears a few symbolic tokens. A small piece of a rocket, a tiny flag, and some human ashes, including those of Clyde Tombaugh, the discoverer of Pluto. It's less of a message and more of a quiet gesture, like signing your name in the corner of a vast cosmic mural. What's remarkable is how these acts mirror what we imagine others might be doing. When we speculate that 3IATLAS could be an alien probe, we're really projecting our own behavior onto the stars. We know we'd send something, so maybe someone else would too. Our spacecraft show that curiosity doesn't need a destination. It just needs a direction. If another civilization found Voyager drifting through the void, they'd see exactly what we wanted them to. A species small and fragile, but full of music, mathematics, and hope. Of course, there's also the sobering side. Some scientists have pointed out that sending our location into the universe might not be the wisest move. If space were truly neutral, it wouldn't matter. But what if it's not? What if it's more like a jungle than a playground? We might have just sent our home address to whoever's out there, trusting they're friendly. Still, even that decision reflects something beautifully human. Our default mode isn't fear, but connection. And perhaps that's the ultimate lesson from our own spacecraft. We communicate not because we expect a reply, but because it's in our nature to reach. We build machines, we fill them with symbols of who we are, and we fling them into the dark, knowing we'll never see them again. It's the same instinct that drives explorers to cross oceans, writers to pen letters to the future, and scientists to stare into telescopes, searching for a glimmer of the unfamiliar. So maybe 3IATLAS, if it was sent intentionally, isn't a warning or a test. Maybe it's just someone else doing exactly what we've been doing all along. Reaching out, curious, cautious, but hopeful. The difference is they sent their message as stone, and we sent ours as song. Both drift onward, unhurried and unafraid, carrying proof that somewhere in the cosmos, life learned to wonder and couldn't resist the urge to say hello. When you really think about it, sending a rock across interstellar space on purpose makes about as much sense as throwing a paper airplane and expecting it to reach another continent. The odds are laughable, the logistics nightmarish, and yet, if someone managed to do it, the technology behind it would make everything we've ever built look like cave art. Because while humans can barely get Wi-Fi in the next room, somewhere out there, a civilization might have figured out how to launch a chunk of matter across light years with the precision of a surgeon tossing a coin and hitting a moving target the size of a planet. Let's unpack what kind of engineering it would take for that to be possible. First, propulsion. Getting an object like 3IATLAS from one star to another isn't about going fast. It's about going forever. You'd need a way to maintain velocity without burning fuel the whole time. Traditional rockets, the kind we use to send satellites and astronauts, would run out of energy long before they clear their own star system. Even our fastest spacecraft, like Voyager 1, is crawling at a pace that would take tens of thousands of years just to reach the nearest star. That's not an interstellar messenger, that's a cosmic snail. An advanced civilization, however, wouldn't rely on chemical explosions strapped to a tin can. They might use something we've only begun to dream about, like light sails. Imagine a thin, reflective sheet spanning hundreds of meters, propelled by the gentle push of starlight. It sounds delicate, but the physics checks out. Photons, the tiny particles of light, carry momentum. Push on something long enough, and even the faintest pressure adds up. It's slow to start, but once it's moving, it never stops. No fuel, no engine, just the universe doing all the heavy lifting. Now, if you want to send something as hefty as 3IATLAS, you'd need a scaled-up version, maybe a swarm of powerful lasers in orbit around your home star, beaming light onto the sail until it reaches escape velocity. Think of it like a cosmic slingshot powered by sunlight. We've already toyed with this idea on Earth through projects like Breakthrough Starshot, which aims to send microprobes to Alpha Centauri using the same principle. The difference is that our version involves gram-sized chips. Theirs could handle objects the size of asteroids. It's the same physics, just executed with the confidence of a species that's been engineering longer than we've been walking upright. Then there's the matter of materials. You can't send something through interstellar space for millions of years without protection. Radiation, micrometeoroids, and dust would erode most known substances into vapor long before the journey ends. Even hardened metal wouldn't last. So, what could survive that cosmic beating? Perhaps something self-healing, a material that can repair microfractures on its own, using stored energy or chemical reactions. Nature already gives us clues. Our own skin can mend itself, and certain metals can creep to fill in cracks. Scale that up with alien-level nanotechnology, and you could have a structure that literally maintains itself as it travels. It might even adapt, rearranging its molecular structure in response to damage, radiation, or changes in temperature. Imagine a spacecraft that evolves to survive the conditions it encounters, learning from space itself. As for shielding, they could employ electromagnetic fields or plasma bubbles, essentially artificial magnetospheres, to deflect charged particles. Humans have discussed similar concepts for protecting Mars missions, but we're still working on prototypes that wouldn't collapse faster than our internet connection during a thunderstorm. Then comes the question of guidance. You can't exactly steer a rock by remote control across billions of miles. The time delay alone would make that impossible. Even a radio signal from the nearest star takes over 4 years to reach us. So any interstellar probe would need to be smart. Not smart like a computer. It would have to be autonomous in a way that borders on alive. It would need to sense gravitational fields, magnetic currents, and radiation gradients, adjusting its trajectory subtly over time. Think of a sailboat that can navigate an ocean of starlight without ever checking a map. And that brings us to the most daunting part: time. The journey across interstellar space isn't measured in years or even centuries. It's measured in millennia. If 3IATLAS really was launched intentionally, it might have left its home system before humans learned how to use fire. To its creators, the trip would feel glacial. But maybe that's the point. A civilization capable of such technology probably doesn't think in lifetimes. It thinks in geological eras. For them, waiting 10,000 years for a reply might be the equivalent of refreshing a web page. That kind of patience requires more than just engineering. It requires a worldview fundamentally different from ours. Humanity still struggles to plan for the next decade. We build cities that crumble in centuries, satellites that last a few years, and operating systems that stop updating every other Tuesday. But a civilization capable of launching 3IATLAS with purpose would need to think of existence as a continuum, not a moment. Their machines might be designed to outlive even their creators, carrying forward their legacy long after their species has changed or vanished. And that's perhaps the most humbling thought of all. 3IATLAS, if it was engineered, could be the ghost of a civilization long gone, a survivor of its maker's ambitions, still carrying out its ancient programming because that's what it was built to do. It doesn't need a mission control or a cheering crowd. It just needs physics and momentum. Meanwhile, here on Earth, we're still tripping over tangled charging cables and arguing about battery life. Yet, somehow, we dream about sending messages to the stars. Maybe that's how every intelligent species starts, with bad Wi-Fi, ambitious ideas, and a stubborn refusal to accept that impossible is permanent. Because one day, if humanity lasts long enough, we might build something like 3IATLAS ourselves. And when we do, we'll finally understand the magnitude of what it means to throw a stone into the infinite, and trust that somewhere, someday, someone will notice the ripple. Here's a twist worthy of a science fiction plotline. What if 3IATLAS isn't alien at all? What if it's ours? Not from another world, but from another time. A message flung backward across the ages by our distant descendants, looping through the galaxy to check on how their reckless ancestors are doing. Maybe it's not aliens spying on us, it's us, checking if we've cleaned up the planet yet. It sounds wild, but then again, so did flying machines and quantum computers once upon a time. If you're willing to stretch your imagination and suspend disbelief just a little, the idea that 3IATLAS could be a time traveler's delivery suddenly becomes less fantasy and more cosmic inevitability. After all, if humanity survives long enough, won't we eventually want to look back? Time travel, of course, isn't just one concept. It's a tangled web of physics, paradoxes, and late-night arguments between theorists who all agree it's impossible but can't quite stop talking about it. According to Einstein's general relativity, time isn't a straight line, it's a dimension woven into space itself. Warp it enough with gravity or speed, and it can bend back on itself. Theoretically, that means you could travel through time the same way you travel through space. If you had the right tools, enough energy, and a blatant disregard for causality. But what if there's another, subtler version? Not a DeLorean-style jump, but a cosmic relay, sending information or matter across deep time using the natural curvature of space-time. Imagine a civilization in our distant future that has mastered the geometry of the universe so completely that they can sling objects not just across light years, but across epochs. They might discover a way to aim a probe into a gravitational eddy near a black hole or wormhole, letting it fall through a shortcut in space-time and emerge millions of years earlier. To them, it's science. To us, it's magic. That's where 3IATLAS enters the scene. Suppose our descendants, living thousands or even millions of years in the future, wanted to send something back to study their origins. Our era, the early Anthropocene, the time when everything was still fragile and uncertain. Maybe they wanted to see whether we survived the environmental crises, whether civilization endured, whether their myths about the ancients, that's us, were true. So, they packaged up a probe, disguised as a natural object, because stealth never goes out of style, and sent it drifting into the past. And just like that, 3IATLAS shows up, right on cue. Think about how poetic that would be. We've always looked forward, dreaming of sending messages into the future. Maybe one day, the future decided to write back. If that's the case, then 3IATLAS isn't just a scientific anomaly. It's a paradox made tangible, a fragment of tomorrow falling into today, the ultimate return to sender. It would mean that humanity eventually learns how to manipulate time well enough to plant breadcrumbs in its own history. Maybe it's part of a grand experiment to see how cause and effect ripple across centuries. Or maybe it's an act of curiosity, a temporal mirror held up to the past to remind us that the future is watching. But time loops come with headaches. If 3IATLAS was sent by our descendants, then its discovery might be the event that inspires those descendants to send it in the first place. That's the bootstrap paradox, an effect creating its own cause. The message exists because it caused itself to exist. Philosophically, it's maddening. Practically, it's beautiful. It's a closed loop of curiosity. Humans in the future reaching back to their own beginnings because they couldn't resist wondering who started it all. And if you think that's too far-fetched, consider how much we already tinker with time, just in smaller doses. Astronauts aboard the International Space Station experience a few milliseconds of time dilation every orbit, aging ever so slightly slower than people on Earth. GPS satellites have to adjust their clocks constantly to stay in sync with us. We already bend time. It's just that our bending is measured in nanoseconds instead of centuries. Give us enough technological growth, and bending it further might not be unthinkable. Then there's the eerie question of motive. If the future really did send something back, why the secrecy? Why not just land the probe, display a holographic welcome message, and hand us the cheat sheet to survival? Maybe they can't. Maybe the timeline is fragile, and direct interference would unravel it. So they do the next best thing. They observe quietly, ensuring that their actions don't alter the outcome. 3IATLAS could be the equivalent of a historian peeking through a window, forbidden to knock. Or perhaps it's even more subtle, a self-fulfilling gesture. Maybe the purpose is to inspire us to dream of time travel, to think about continuity, to imagine humanity surviving long enough to pull off such a stunt. The simple act of speculating about 3IATLAS could plant the idea that will one day lead to its creation. The loop closes not through machinery, but through imagination. There's also a strangely comforting angle to this theory. If 3IATLAS came from our future, it means we have a future, that humanity endures long enough to build it, long enough to master time, to look back and to care. It means we make it through the chaos. We evolve, we persist, we learn. And after all that, we still want to know where we came from. Maybe that's what curiosity ultimately becomes when a species grows wise enough. It turns inward. It stops asking, what's out there, and starts asking, who were we? So, when 3IATLAS streaked through our solar system and slipped away again, maybe it wasn't just passing by. Maybe it was saying, in its silent, frozen way, we've seen what becomes of you. You did better than you thought. It's a comforting thought, one that ties the future and the present together in a single, shimmering thread. Because maybe the real secret of time travel isn't bending space-time. It's realizing that the future and the past are already talking to each other through curiosity itself. If 3IATLAS really was a message, some kind of interstellar note slipped into our cosmic mailbox, then we're left with a frustrating problem. How on earth, literally, would we even read it? It's not like we can just hold a rock up to our ear and hear alien whispers. There's no glowing panel, no engraved "to Earth" on the side. For all we know, it could be Morse code in rock form, and we're too busy arguing on the internet to notice. The truth is, if an intelligent civilization wanted to send a message that could survive millions of years of interstellar travel, they wouldn't use fragile things like paper or radio signals. They'd use matter itself as the medium. The composition of the object, the isotopes, the arrangement of atoms, the ratios of elements could be the message. A rock can hold information the way a book holds words, if you know how to read it. So, how would we begin to decode such a silent messenger? First, we'd have to treat it less like a comet and more like a hard drive. Every atom could be part of a cosmic code. Take isotopes, for instance. Variants of elements with different numbers of neutrons. On Earth, certain isotope ratios are natural results of geological or cosmic processes. But if you found ratios that don't occur anywhere else, ones that can only be made artificially, that would be like finding handwriting in the dust. Imagine discovering that the hydrogen in the object wasn't the usual mix of hydrogen and deuterium, but something precise, something unnatural, like one isotope per every 10,000, perfectly uniform. Nature doesn't do perfect. Nature's messy, random, full of noise. Precision is a fingerprint of intelligence. If we ever found that kind of exactness, it would be the equivalent of spotting straight lines on Mars. Our first real hint that someone, somewhere, shaped it deliberately. Another potential layer of meaning could come from structure. On the outside, 3IATLAS might look like a lump of frozen rubble. But what if, under that rough exterior, it had internal geometry, Not chambers or wires, nothing so obvious, but molecular or crystalline patterns too complex to form by accident. Maybe the alignment of the crystal lattice itself encodes data, the way a computer stores bits in silicon. It wouldn't even have to be digital. It could be mathematical. Ratios, symmetries, repeating sequences of primes. Nature loves chaos, but math is the language of intention. Then, there's the wild idea of trajectory as message. What if the orbit of the object isn't random, but deliberate, its path through space forming part of the signal? Think about how ancient humans built monuments aligned with the stars. Maybe this is the galactic equivalent, an object sent to move through the solar system at a precise angle, speed, or timing that means something to an interstellar culture fluent in orbital dynamics. That trajectory might read like a signature. From Sector X, Star Y, regards, the neighbors. The catch, of course, is that we'd need to recognize the pattern. And we humans are still, like toddlers, learning the alphabet of the cosmos. We can detect motion, yes, but understanding intent behind that motion, that's another story. We might have already received dozens of letters like this and simply filed them away under rocks that look funny. It's humbling to realize how much subtlety could go unnoticed. A probe encoded with isotopic messages could fly right past us, and we'd never know unless we managed to physically capture and analyze it. But even then, would we see the message? Our tools and assumptions shape our vision. We might test its chemical composition, confirm it's not from our solar system, and pat ourselves on the back, without ever realizing we just dissected a cosmic communique. Some scientists have joked that maybe alien messages are all around us, encoded in forms we don't even think to question. Cosmic rays, neutrino bursts, asteroid patterns. What if these aren't random at all, but deliberate? The universe could be pulsing with communication, and we're the galactic equivalent of someone staring at a Wi-Fi signal and asking why the air tastes funny. Then there's the philosophical side. Even if we could decode it, would we understand it? Communication isn't just about sending, it's about context. Imagine trying to explain the concept of music to a rock. Even if 3IATLAS carried a message meant for intelligent beings, it might use principles or symbols we can't yet perceive. What if the message isn't meant to be read by eyes or instruments, but by civilizations who think differently, who understand physics not just as a tool, but as an art form? In that case, the message might not be words at all, but experience. The object's material could be designed to interact with environments in specific ways, emitting subtle electromagnetic patterns when near a star, or reflecting light at frequencies that encode meaning. Maybe we're supposed to watch how it behaves, not just what it is. Like an alien haiku, where motion, light, and matter combine to express something simple and profound. And here's a fun thought. What if the message isn't meant for us at all? Maybe it's en route to someone else entirely, and we just happen to intercept it mid-journey. We're the nosy neighbor who opened someone else's mail and can't make sense of it. Maybe the real recipients are another civilization farther down the line, one fluent in the cosmic code. To them, the shape of 3IATLAS's orbit, its spin, its molecular pattern, all of it, might scream meaning. To us, it just looks like a dusty traveler minding its own business. Still, the fact that we're even asking these questions says something hopeful about us. It means we're ready to listen, even if we don't yet know the language. Humanity's greatest strength has always been curiosity, the willingness to squint at the unknown and say, I bet there's something in there, so maybe one day, when our instruments are sharper and our minds broader, we'll find another 3IATLAS, another messenger drifting through the dark. And this time, we'll recognize the pattern. Maybe we'll decode the isotopes, unravel the trajectory, and finally understand what it's been trying to say all along. And when we do, perhaps we'll realize that the universe has been talking to us the whole time. We just needed to stop scrolling long enough to notice.